263 galaxies. That's all it took. 263 faint spirals, scattered across the deepest images ever taken of our universe. And a single question that nobody thought to ask. Which way are they spinning? The answer should have been boring. Half one way, half the other. Pure, meaningless randomness, the way you'd expect from a cosmos with no plan, no preference, no direction. That's not what came back. Roughly 2 out of every 3 of them were turning the same way, and if that number is real, if it isn't a trick of the light or an error in our instruments, then it points to something so strange that most physicists would rather not say it out loud. It might mean our entire universe is sitting inside a black hole. To understand why that sentence isn't insane, you have to understand what a black hole really is. And almost everything you picture when you hear the word is wrong. It is not a hole in the floor of space that you fall through and pop out the other side. It's not a vacuum cleaner and it's not a tunnel. A black hole is a place where gravity has become so overwhelming that it bends the geometry of space and time back onto itself. Not light can't escape because it isn't fast enough. Something far weirder, there is no direction that leads out. Every possible path, every road you could take, curves back inward. Escape isn't difficult there. Escape stops being a thing that exists. And the edge of that region, the invisible line where all your futures collapse into one, we call the event horizon. It's a horizon in the truest sense, not a wall, not a surface, just a boundary beyond which no information will ever reach you again. Remember that word, because we're about to use it in a place you'd never expect. Look up tonight, and you are not seeing the universe. You're seeing a bubble. Light is fast, but it is not infinitely fast. And the universe has only existed for a finite amount of time, a little under 14 billion years. So there is a maximum distance that light could possibly have traveled to reach your eyes. Beyond that distance, there could be galaxies, stars, entire civilizations, and their light has simply not had enough time to get here. That boundary has a name. It's called the cosmic horizon, and no information from beyond it can ever reach us. Stop and hear that again. A black hole has a horizon, a boundary beyond which nothing reaches you. Our universe has a horizon, a boundary beyond which nothing reaches you. Same word, same behavior, and so far that's just poetry, a coincidence of language, but then somebody did the math. Here's the thing about black holes that almost nobody knows. You'd think that to make one, you'd need to crush matter into something unimaginably dense, and for small black holes that's true. Squeeze a star into a city, and you get one, but the relationship isn't what your intuition expects. Double the mass of a black hole and you double its size. 10 times the mass, 10 times the radius, which leads to something bizarre. The bigger the black hole, the less dense it needs to be. A black hole the mass of the sun would be a few kilometers across, insanely dense, but a black hole a billion times heavier, its average density could be thinner than water, thinner than air. So here's the exercise. It's a classic, the kind of problem students run for fun. Take all the mass in the observable universe, every star, every galaxy, every atom of dust. Now ask, if you turned all of it into a black hole, how big would that black hole be? The answer comes back, and it's roughly the size of our universe. The average density of everything inside our cosmic horizon lands right about where it needs to be. For that horizon to be an event horizon. Now, that alone doesn't prove anything. It could be a coincidence. Deep numerical coincidences do happen, and physics is littered with them, but it's an uncomfortable one, because it means, if you were living inside a black hole big enough, nothing about your daily life would feel wrong. You wouldn't be crushed. You wouldn't be torn apart. You'd just look up at a sky full of stars and never suspect a thing. So what would it even mean to live inside one? This is where general relativity gets genuinely strange. Run the equations of what happens inside a black hole, and under certain models, you don't find a dead end. You find that space and time swap roles, and a whole new space-time can open up on the far side. In some versions of this idea, the matter falling in doesn't get destroyed. It gets squeezed, bounced and expanded outward, into a brand new region of space, growing from a single unimaginably dense point. A single unimaginably dense point that suddenly expands into an entire universe. Does that sound familiar? Because we have a name for that event. We call it the Big Bang. In this picture, our Big Bang wasn't the beginning of everything. It was the other side of a collapse. The birth of a new universe inside a black hole that formed in some older parent cosmos. A cosmos we can never see, never touch, and never return to. And every black hole in our sky spinning quietly at the heart of every galaxy might be doing the exact same thing, budding off new universes we'll never know about. It's a beautiful idea. It's also, for a long time, been completely untestable. A story with no evidence, until the galaxies started spinning the wrong way. Here's what a black hole remembers. When something falls in, almost everything about it is erased, its shape, its chemistry, its history, gone. A black hole is famously, brutally forgetful, but not entirely. It keeps mass, it keeps charge, and crucially, it keeps spin. Angular momentum. If gas falls in swirling, that swirl doesn't vanish, it's preserved. Black holes are born rotating. So now follow the logic. If our universe was born inside a rotating black hole, then our universe should have inherited that spin. There should be a preferred axis, a direction, baked into the fabric of everything from the very first moment. And that is a prediction you can actually go and test. Which brings us back to those 263 galaxies. Using the deepest survey ever taken by the James Webb Space Telescope, a researcher at Kansas State University did something almost childishly simple. He looked at spiral galaxies in the early universe and just counted which way they turned. The expectation was 50-50. Cosmology's most fundamental assumption is that the universe has no preferred direction. Look anywhere, and it should look the same. The result, about 158 of them spun one way, only 105 spun the other, roughly 2/3 against 1/3. And the imbalance wasn't subtle. It was so obvious that you could see it just by looking at the picture. To feel why that's disturbing, you need to know why things spin at all. Everything in the universe rotates, planets, stars, galaxies, but nothing decided to. It's a consequence of a single, elegant law, conservation of angular momentum. You've seen it. A skater spins with their arms outstretched, then pulls them in, and accelerates, without pushing off anything. Now scale that up. Every galaxy began as an enormous cloud of gas, and no cloud is ever perfectly still. There's always some faint, random turbulence. As gravity drags that cloud inward, it shrinks, and as it shrinks, that whisper of a rotation is amplified into a roar. But here's the key. Each of those clouds is independent, separated by millions of light years. They never spoke to each other. Their little random wobbles had no reason to agree, so their spins should be scattered, pure coin flips across the sky. 2/3 is not a coin flip. Something, somewhere seems to have told them which way to turn. Now, before we get carried away, real science demands we take the boring explanation seriously. And there is one. It might be us. Our own galaxy, the Milky Way, is moving. And when you observe a galaxy that's rotating toward your motion versus away from it, its light can brighten or dim slightly, which means we might simply be better at spotting galaxies spinning one way than the other. Not a rotating universe, just a biased telescope operator. And the operator is the entire Milky Way. And there's a second, much bigger caution. 263 galaxies sounds like a lot. It isn't. There are estimated to be hundreds of billions of galaxies out there. We're drawing a conclusion about the architecture of all reality, from a rounding error of a sample. Extraordinary claims demand extraordinary evidence, and right now, we have an intriguing hint, not a discovery. So, are we inside a black hole? Honestly, we don't know, and anyone who tells you they're certain in either direction is selling something. What we have is a strange coincidence in the density of our universe, a theory that says black holes might give birth to new realities, and a small, stubborn imbalance in the spin of distant galaxies that nobody predicted and nobody can fully explain. 3 loose threads. They may lead nowhere, but sit with the possibility for a moment. If it's true, then the Big Bang wasn't a beginning, it was a doorway. Our universe isn't a thing that exists in space, it's the inside of something, and somewhere out there, in a cosmos we will never see, a star collapsed, and everything you've ever loved was what happened next, and the strangest part of all, you'd never feel it. No walls, no edge, no sense of being trapped, just a warm afternoon, and a sky that goes on forever, which might be the most unsettling thing about a black hole big enough. It would feel exactly like home. If you want to keep exploring the edges of what we actually know, the question science hasn't closed yet, subscribe to MOAT and hit the bell. A new journey through the cosmos every single week. And tell me below, do you think we're inside one? Until next time, keep questioning the sky.